Math 1332, Chapter 10, Probability and Counting Techniques. Section 2, the Fundamental Counting Principle, Permutations. Video 3, Factorials. I thought about covering up stuff in this video and then uncovering it as we get to it, but nah. Excuse me, in the previous video, we worked the following problem. I will highlight some things though. How many ways can you arrange 8 distinct books on a shelf? The answer was found by using the fundamental counting principle, which led to this multiplication problem. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 equals 40,320. And they even commented that I was a little ashamed that I didn't remember that answer. The reason I'm a little ashamed is because that multiplication problem, that product and ones like it have a special name, factorial. And I've encountered this problem many times. I guess I haven't encountered it recently because I didn't remember that it was 40,320. The symbol for a factorial is an exclamation mark after a number. So in the example that we just saw up here of 8 times 7 all the way down to 1, we could have written 8 factorial, which by definition means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which again equals 40,320. For any natural number, remember natural numbers start with 1. For any natural number, 1, 2, 3, 4, 5, and on, we define their factorial in the same way. That n factorial is the product of all natural numbers from n down to 1. For example, if you saw 5 factorial, that means the product of all natural numbers from 5 down to 1. 5 times 4 times 3 times 2 times 1, which equals 120. But in general, we can write the following, and some people fall off right here because of the algebraic notation. If we want to define a factorial in general, I know where the product starts. The product starts with whatever that number is, but then we have to multiply it times the number before that. Well, how do you go backwards in a counting pattern? You subtract 1. So whatever the first number is, you have to subtract 1 from it to get the next number in front of it. And then you have to subtract 1 again, but subtracting 1 and then subtracting 1 is a cumulative effect of subtracting 2 to get the next factor. And then you keep going until you get to the end, 3, 2, and 1. So it may look a little weird to say n times n minus 1 times n minus 2, but that's just a generic way of saying a number times the number in front of it, times the number in front of that, and then of course the ellipses say continue this pattern until we get to 3, 2, and 1. There is one other factorial that we will define, and that's 0 factorial. We can't use the definition above because if you start at 0, you can't go down to 1. In other words, if we put 0 here for the n, and I'll just draw it in real quick. We put 0 right there, and the next factor would be 0 minus 1, but that's negative 1. And then 0 minus 2, but that's negative 2. We're going in the wrong direction if we want to end up at 1. But 0 factorial, for reasons we'll elaborate on later, we are going to define 0 factorial to equal 1. Now, this isn't just a random assignment of a value. It has to equal 1 in order for everything to not fall apart later. And if you really want to get super nerdy and take the calculus path, there's another reason why it's equal to 1. But for our purposes, we are just going to define 0 factorial to equal 1. Now, if you have a calculator, and you should, if your calculator has a factorial button on it, it'll probably say x factorial or n factorial, or has factorial somewhere in the menu. If you have a TI graphing calculator, press the PROB button, or maybe it just says PRB. I don't have one in front of me. But if you do, it brings up a menu, and I believe the very top thing is an exclamation mark. So if you wanted to do like 5 factorial, you would press 5, probability menu, choose the exclamation mark, and it will type 5 factorial in your calculator. So you're welcome to use your calculator, okay? But it will be critical that you understand what a factorial means. So when you see something like 12 factorial, you need to know that that means start multiplying with 12, keep going all the way down until you hit 1. The fact that this equals 479 million 1,600. Is that right? It is. The fact that this equals 479,001,600 is immaterial because you can relegate that work to a calculator. We will use factorials in a few capacities. One is to answer a specific type of fundamental counting principle question. Recall that the number of ways to arrange 8 distinct books on a shelf was 8 factorial. That's how we began this video as a follow-up from the end of the previous video. But in general, we can say the following. The number of ways to arrange n distinct objects, meaning that no two are exactly the same, in a row is n factorial. So we won't have to reinvent that wheel. For example, if there are 10 kids who want to get in a line to ride a roller coaster, sorry folks, I did not proof these. I was ready to start the video. If there are 10 kids who want to get in line to ride a roller coaster, then there are 10 factorial ways they can get in line. By themselves, factorials don't do very much. They do answer the question, how many ways can I arrange some distinct objects in a row? But they will give us a more efficient way to answer questions of the form, how many ways can you, when it's not obvious how to do that, such as the questions posed at the end of the previous video. Oh my gosh, did I really just put a sentence fragment? Oh my gosh, I would fail my English class if my teacher saw that. I'm not taking one. I mean, when I was taking them. Sorry. Let's read this again. By themselves, factorials don't do very much, but they will give us a more efficient way to answer questions of the form, how many ways can you do something, when it's not obvious how to do that, such as the questions posed at the end of the previous video. And here's one of those questions. It was, how many ways can we arrange 8 books on a shelf if 2 of them are the same, 3 more of them are the same, and the other 3 are all different? Now that would be a real tricky one to do by brute force with the fundamental counting principle, but with factorials, it's going to be a real easy setup and solution.